My name is Kris, and I just flew up from Sydney today. I live in Sydney, and on the airplane, I was working on my entry for this year's Sydney Royal Easter Show knitting competition, which got some strange looks because I am in fact a knitter. You are here for a knitting talk, but I am also a geek, which you can tell by the self-made Doctor Who shirt. And so consequently, I love geeky knitting. And I know when I say that, are we going to switch that one over as well? Well, I know when I talk about geeky knitting, you guys are probably thinking of things like this. And that's totally fun, like I did, in fact, knit these things. But there's a lot more to it than Baby Yoda outfits and Doctor Who scarves. So just so I know what I'm dealing with here, please raise your hand if you have ever knitted in your life. Yeah, I told you, more than half the room, like majority, always. Well, that's cool. If you've got your knitting with you, please pull out those whips. Knit them if you got them, that's fine. As for the rest of you muggles, no experience is assumed, and I'm not going to teach you either. Don't worry, this is not a knitting class. We are here, in fact, to talk about software, to talk about code. So my goal today is actually to convince you that this has more in common with this than most people realize. Because really, when it comes down to it, this is actually just this. And to a programmer, to you and me, that looks a lot like computer code. And you don't have to take my word for it. You guys probably saw several months ago, some engineer at Uber tweeted this. Because even though Ophelia and I have been saying this stuff for years, as soon as a dude tweets it, then suddenly it's a revelation. So snarkiness aside, as an intro, I've been working in tech a lot longer than a knitter, actually. I obviously grew up in the US, you can tell from the accent. I worked as a web dev in London, in the UK in 2001, and then moved to Australia. And when I got here, we didn't have Netflix back then, children. And so while I was waiting for that work visa to get to be approved, I needed something to do. And I decided I'll take up a craft or something like that, you know? And I thought, I'll learn knitting. Like, why not? Like, get a nice fluffy scarf out of it. And I liked the idea that it was very different from my day job. Like, it would be a nice relaxing change of pace, you know, because like, how hard could it be? I mean, grandmas do it. Like, in my mind, these activities were completely separate. So I got a kids learn to knit book and a ball of wool and a pair of needles, and I started working on a pot holder. And that sucker nearly killed me. I think I pulled it apart about a dozen times. And at the end of that project, I had three things. I had a really kick-ass pot holder, all right? And that thing is pride of place on the bookshelf in my house. I had mad respect for the skills of the grandmas of the world. Like, you guys have no idea. And I had the realization that knitting was just like code, and this blew my mind. And I started seeing all sorts of similarities between these activities, and pretty soon, this mental model turned into more of this. So today I'm going to walk you through some of those areas of similarities and the patterns that I recognized in the hopes it's going to spark your own imagination and creativity. Look, this is not something you're necessarily going to use at work. You don't need to take notes. But I really feel that by looking at what you do in a new way, it's going to make you better at it. Okay? So, lesson one. If you learn nothing else today, let it be this. This is not knitting. This is crochet. People get them confused all the time. It drives the knitters crazy. I can see why you'd think that. Like, it involves a ball of wool, you make a thing, but really they're totally different. So crochet has that one hook. If you see a hook, it's crochet. And crochet can kind of go off in any direction at any given time. It's really good for making complex 3D sculptural pieces. So if you're into maths, go home tonight and Google crochet maths, and then you can talk to Jeff and you can be up here giving a talk on crocheted hyperbolic geometry. This is knitting. So knitting is done with at least 2 needles, sometimes more, involves a sequential processing of stitches from one needle onto the other. You get to the end, you swap hands, you start over again. That's with 2 needles. If you're using a set of 4 or a circular needle, you're actually going around and around in a spiral. So that's knitting. Now, as a beginner, the very first thing you would have learned when you were learning, the very first thing that I learned, was that there's actually only 2 stitches, knit and purl. So right off the bat, I realized, hey, knitting's binary. And binary, to a computer geek, I start thinking I can use this to encode data in lots of different ways, pretty much anything digital. And I started seeing this everywhere. So for example, if I combined knits and purls into ribbing, I could make a beanie. So this hat is called the Decoder Hat by Zabit Stewart. It encodes up to 12 characters in ASCII at 8 stitches per character. Now obviously 12 characters, that's a pretty hard memory limit here, pretty hard message limit, of course dictated by the size of your own head. If you wanted to encode a longer message, you could knit a scarf. This scarf represents the binary source code to Ravelry.com. And if you're not a knitter, Ravelry is basically GitHub for knitters. So this is the source code to Ravelry with knits as the ones and purls as the zeros. Now if you're more of a black hat type, you could even knit a virus. In 2001, a team of activists and artists did just that. They knitted the source code of the code red computer virus into a fluffy red scarf. You could wrap that around your neck and walk across any border in the world. No firewalls picking that up. If you wanted something more stylish, you could use cables. I love cables personally. So the hat on the left here represents the numbers from 0 to 15 in binary notation, depending on where those cable crosses occur. And the scarf on the right has a hidden secret message in binary that's revealed by cables that actually look like little ones and zeros. If you prefer color, you could use the width of knitted stripes in different colors to encode a character set. The stripes on this guy's jumper, for example, actually spell out the classic first programming exercise. Say it with me, hello world. If you want to get super literal, you can actually knit ones and zeros into a scarf. This one's called Binary. It's from nitty.com. You may be interested to learn your average scarf, depending on how tall you are, will hold about 120 bytes of information, which sadly is just shy of a tweet. Now there are other encoding methods than just binary. How about Morse code? So these mittens use 2 different colors of wool to simulate the dots and dashes of Morse code and spell out my left mitten, my right mitten, and thumb. Very meta. Here's a more decorative example. In this example, the word peace has been converted to base 6. It's been plotted on a graph and then tweaked to turn into a repeating decorative motif. Very pretty. So you could have a word embedded in your garment and no one would even know about it. But Kris, I know what you're thinking, Kris. What about accessibility? Well, what's more accessible than Braille? These socks use the texture of knitted stitches to encode in Braille a stanza from Dr. Seuss's poem, Oh, the Places You'll Go. And lastly, not all data's text. Did you know that in World War II, the Belgian resistance actually recruited little old ladies who lived near train yards to watch German trains and secretly encode their movements into their knitting? It's true because I saw it on QI. In more mundane examples, on the left here is a scoreboard scarf, which is a record of a sports team's season with all of their points in one color and all their opponents in the other. Really hope he's barracking for the gray team. And on the right is a sky scarf where the color of every row is the color of the sky above the knitter on the day they knitted it. Interesting, a friend of mine is actually knitting a scarf at the moment where every day she chooses the color based on the truthiness of our dear president's latest statement. It's mainly red. Now, my last example of knitted and encoded data actually won me a second prize at the Sydney World Easter Show a few years back. You may applaud, yes. So, ladies and gentlemen, I give you the knitted QR code mittens. It's true, I really did it. So these were surprisingly difficult to get to work. The problem is that QR codes really rely on things being square, if you've never played around with them. They really need those 3 squares to orient themselves. And knitted stitches are inherently wider than they are tall. They're rectangular, so it just didn't want to scan. So I went through many a prototype until I finally hit upon the solution, which in technical terms was to stretch the hell out of it. So eventually I managed to get a version. It does work. You're welcome to come up and scan it afterwards. It works best if it's flat. And where does it go, you might ask? Well, it goes to a URL on my personal site that has the pattern for the mittens. So they're self-replicating. Okay, so back to the story. So once I had the basics of knits and purls down, it was time to learn to read patterns, as I'm sure some of you have done. So the first line of any knitting pattern will look like this. Cast on 24 stitches. Now that means to create that first initial starting row of loops on the needle. So my brain looked at that, coming from programming world, and went, that's a for loop. You got code executing repeatedly a certain number of times, maybe with like a variable as a counter. So my brain looked at cast on 24 stitches and turned it into this. You got a little variable for the stitch count, and then based on that, I just called a stitch.castOn method over and over till I hit the count. Easy peasy. Another really common instruction you see in knitting patterns is repeat to end of row. Okay, I know that. That's a while loop. It's code executing repeatedly again based on a given Boolean condition. And the Boolean condition in this case is, have you gotten to the end of the row yet? If not, keep going. So, to put it in my little imaginary knitting code, while not at end of row is true, just keep knitting. So I finished my potholder, finally got to the end of that damn potholder. And I was itching, of course, to move on to garments. I wanted to make myself a jumper. So I picked out my pattern, I went and dropped like $100 on wool, opened up my pattern, and the first thing I saw was this. Cast on 242, 256, 270, 284 stitches. So I puzzled through that and eventually realized those correspond to sizes. Oh, duh, okay. So there are 4 garment sizes defined at the start of the pattern. So here, this is from a jumper pattern. So there's these 4 sizes. Let's say I want to knit the 38-inch size. And so basically, wherever there is a group of 4 numbers, I do the first one. That's the number that I use. All right, well, that's basically just a switch statement. I get code that allows the value of a variable or an expression to change based by a multi-way branch. So again, set a variable for my size, and then based on that number, I cast on the appropriate number of stitches. So in this case, 242. I get that. Now, some patterns I worked out have a lot of sizes, especially if they're for adults and kids, as you might imagine. And usually it's more than just a single number changing, It's not just one variable. You might have whole parts of the pattern that you use or don't use, depending. And that kind of leads me into the next concept that I noticed was similar to programming, which is subroutines. I realized the more complex a knitting project is, the more likely it was to be broken down into sections, into subroutines. In programming, we talk about that as like a function or a procedure or a method. It's basically a set of instructions that perform a specific task, and then wherever you need that task, you just invoke that subroutine. Well, we use this all over the place in knitting. Like whenever a pattern uses a particular stitch or like a cable or whatever, it'll get declared in a separate block and then invoked wherever you need it. So this is an example. This pattern defines 2 particular stitch patterns, twisted rib and twisted rib in the round. And then in the actual instructions, you invoke those subroutines with the phrase, work in twisted rib. And I'm not going to do a million more of these, but just if this were a computer program, it might look like this. So I've defined a function called twisted rib. I pass in the stitch count. I need that number so that I can stop 1 stitch before the end and do a final knit or purl before I call the needles.swap. You see, it's getting quite wordy and verbose. So another way that patterns declare subroutines to avoid getting very verbose is with charts. So these are some examples from a cabled cardigan. So there might be one chart for like the front of the cardigan, another for the sleeve, and one for the collar. Now the real fun happens when you get more than one of these suckers happening at the same time. And that takes us into the realm of a really old school programming concept called coroutines. So coroutines are a special class of subroutines. Now subroutines start and finish, they don't hold state, they just run. But coroutines can exit, they can yield to other coroutines, like hitting the pause button, and then come back and pick up where they left off. And you can have multiple instances of a given coroutine going at any one time. Now in knitting, you mostly see this used with very complicated cable and lace patterns. I started knitting this sucker 2 years ago. Yeah, it's called Morrigan. It involves 20 different charts. Knitters, it's over like 17 pages, with 56 instances of the charts involved at any given time. This is row 1. Each one of those letters refers to a different chart, which vary in length from 2 rows long to 66. You could even look at this as a type of interleaved multi-threading where the CPU, which is my brain, has to take a new instruction from every coroutine in turn, and depending on how much RAM I have available, things can grind to a halt. Whoops. Uh-oh. Stepped on my own joke. Things can grind to a halt. So in other words, this is not the type of pattern you knit at the pub. So I started seeing code all over the place. I already mentioned Ravelry, which is basically like GitHub. Checking your stitch count at the end of the row, that's pretty much running a unit test, Running a safety line through a row, that's like doing a git commit. Like I could go on and on with this. But I thought it would be really interesting to talk a little bit more now about knitting pattern languages more generally and how they relate to programming languages, because that's really what we're all interested in. So in case you didn't know, there is no single worldwide knitting authority. There is no grand high queen of knitting who declares the standard. So everybody writes their patterns differently. And there are multiple competing standards. And you have to relearn a different one every time you go to a new project. And it's kind of another way that it's like programming. So the particular form a designer uses depends on a lot of things, like if it's a complicated project or if it's a simple scarf. That might determine what sort of structure they use for their pattern. The distribution medium, you know, patterns used to be distributed on ink and paper, and nowadays we mainly buy PDFs, so you don't have to worry about conserving space as much. The audience, are they beginners? Are they more advanced? It can even vary by like brand or cultural affiliation. Now these are kind of, I mean, if you squint your eyes, similar to the questions you ask yourself when you're picking a programming language, you know? What sort of problems do I need to tackle? Like, what sort of data do I need to manipulate? What level of portability and readability do I need with this thing? So this is pretty cool, and I'm sure some of you are aware. The history of programming languages actually begins with textiles. So 10 points to who yells out the name of this thing. Jacquard loom. Oh, of course you know it. This is a Jacquard loom, invented by Joseph Marie Jacquard in 1798. And what is on the front of it? Punch cards. So Jacquard developed a system that would allow punched cards to control the actions of this loom. And 40 years later, Charles Babbage wrote of using punched cards to input programs and data into his proposed analytical engine. So that's right, programmers, we had them first. So if you look at those punch cards and then you look at this modern knitting stitch chart, they look pretty similar. So when executed, this chart creates a pattern called moss stitch. So the blank stitches are a knit and the dots are purls. This is the knitting equivalent of machine code. This is like a first-generation programming language. There's no compiler or assembler needed. It's super easy for the CPU, which remember is my brain, to execute this. I see a blank, I knit, I move to the next square. I see a dot, I purl, I move to the next square. Get to the end of the row, turn again, start over. So it's really easy. This is another example. This is actually the one that I'm entering in the show. There you go. Yeah. So this is from 1935. This is the chart, so checkerboard design. So instead of symbols, this one uses colors. And charts are really useful for complex multicolored designs like this because it provides a means of error checking. You know, at any time, I can hold the sucker up and check if the output looks like what I'm expecting. Test-driven development. And it also saves a lot of space. Like if these rows were written out in words, it would take up a lot more room. And I know that because this particular pattern includes it. Pages and pages and pages. So as patterns got more complicated, as more complicated garments came into fashion, publishers, like programming language developers, realized that they could get more information conveyed by abstracting it even further, by using more than just two symbols, by going into more of them. So here's an example from the 50s. This uses 5 different typographic symbols to represent different instructions. So we've got an additional level of abstraction here. This is like a second-generation programming language, you know? This is like the mnemonics of an assembly language. Like I can read it, but to actually knit that, I kind of have to translate the actions into the stitch actions that I'm meant to take. So that Roman numeral 2 there, for example, means to create 2 yarn overs or 2 holes. And the 3 is a method to decrease 3 stitches down to 1. Now it's also worth noting those particular symbols, I have never seen those symbols before. Ophelie's shaking her head, she hasn't either. These are really, really obscure symbols. And that's kind of another way it's like an assembly language. Like it's not particularly portable. It's specific to this processor architecture, if you will. I can't just give it to another knitter and they know how to execute it without knowing what the schema's meant to be. So modern knitting patterns, and actually the other problem with this is that you kind of lose that error checking that I talked about. It's not really as faithful to the output anymore. Like it kind of makes a picture mainly because of the dark lines, but without that, it would be really hard to tell if what you were knitting actually looked like what you were expecting to get. So modern knitting charts try and balance abstraction and portability with faithfulness to the output to make it easier to tell if you're doing it right. So as I said, we don't have a single worldwide standard, but these symbols are pretty widely used. And the cool thing is they kind of look like what they create. You know, the holes, the circles, they represent yarn overs, and they kind of look like the holes that are created. You know, that sort of, the forwards and backward slashes are decreases because they create a visual lean to the left or to the right. And that sort of bird foot looking thing, that's the 3 stitches into 1 decrease. So it's pretty good. Like, it contains a lot more information in a very compact space. Between the symbols and the colors, you've got like 9 pieces of information here, which is really great. But some knitters think we can do better. The problem, they say, is that chart. Like, I'll give you an example. This is feather and fan stitch. This was in my intro. And you see it undulates. That's its sort of defining characteristic. The decreases make it go up and down. And you don't get that in an orthogonal grid. You get this. You know, which is concise and readable and sort of adheres to the standard, but doesn't really look like the output. So a new syntax has been proposed, which is sort of the 4th generation knitting programming language, if you will, and it looks like this: stitch maps. So the idea is that stitch maps let you see not just the sequence of stitches in any given row, but how those interact from row to row in subsequent clock cycles. You know, so with increases and decreases, you actually see how that affects the pattern as it progresses in time. And the really, really cool thing is that stitch maps are actually compiled from a domain-specific language called KnitSpeak. So if you go to that stitchmaps.com website, you can enter a pattern like this. This is KnitSpeak. It looks just like a normal knitting pattern. And you can actually compile that, and it will compile it and turn it into a visualization that looks like this, which is really cool. Like, if you're a knitter, this is state of the art. I wish all knitting patterns would be written this way. I love charts. Luckily, the Japanese are way ahead of us there. All of their knitting and crochet patterns use charts and schematics, which makes them extremely portable. Like, I can go into Kinokuniya and buy a Japanese knitting magazine, not speaking a word of Japanese, and I can make any project in it, which is fantastic. The problem is that most Western knitters still rely on patterns that have words, and words are terribly inefficient. So we'll talk about the development of the word patterns. So the first text knitting pattern that I can find was published in 1655, and it looked like this. Brace yourselves. So this is the order how to knit a hose, which is how to knit a sock. And it looks impenetrable, but if you're a knitter, you can kind of start to puzzle some things out. But come on, the UI is terrible here. Like, the UX is awful. Like, it's long, it's vague, it's hard to follow. Where's the cast on row? I was surprised and delighted, by the way, to learn if you go on Ravelry, there are 7 million plus knitters on there. Exactly 1 person has knitted this pattern successfully. So wherever he or she is, Des in Canada, I salute you. All right, so we're going to jump forward about 200 years. So this is 1846 is The Knitter's Friend. So this is sort of 2nd generation knitting pattern. This is a lot more readable, you know. We've got a clearly marked cast on row. We've got nice simple terms. We've got some abbreviations for conciseness. That's all good. What's weird, though, is those abbreviations. They're not just unintuitive. They're actually misleading. So the P3 here, which a modern knitter might think meant purl, actually back then P stood for a plain stitch, which nowadays we call a knit stitch. And a B, which I actually thought was a typo at first, B stood for a back ribbed or purl stitch, which is what we call a purl. So it's exactly backwards. This is like that big endian, little endian byte storage thing, you know? Like, if you didn't know the intended scheme and you started knitting this thing, you could get the exact opposite output than what was intended. So here's a modern knitting pattern. So this is our 3rd generation programming language, if you will. Very clear and easy to follow. We've got consistent syntax and white space, fairly standard abbreviations. It's broken down into modules, explains how to swap them in and out. That's all really good. But I don't know about you, those switch statements still annoy me. And there are a ton of them, like so many of them. So again, some knitters think we can do better. Enter KnitML. I am so serious. KnitML is an open source project with a goal to promote a new international standard and intermediate format for knitting pattern expression. Because knitting patterns are algorithms, And by formalizing the pattern algorithm in that way, you make it easy for a computer to make decisions. And that allows all sorts of really cool and useful operations. So I could generate a pattern with just my size chosen, not all those stupid switch statements. I could have it be charts instead of words. I could have it be English or metric measurements. I could have it be in my preferred language. It could even, compute out those occasionally mathematically complex instructions like increase 37 evenly over 117. And it would have advantages for designers too, because they could write a pattern in the way that made the most sense to them, knowing that their customers would be able to download it in the way that they prefer. That would be really handy. But more amazingly, they could have tests. They could have validation and error checking. So many knitting patterns have errors in them, get published with errors in them. So you could have tests, you could have validation, and you can even pass it on to renderers and visualizers too. Now, this is what KnitML looks like. It's not particularly compact, nor does it bear much resemblance to a traditional knitting pattern. But remember, this is just an intermediate format for computers to deal with. They do not expect that people would ever touch this stuff. Instead, they provide a pattern authoring tool for people called Knitting EL, which stands for Knitting Expression Language. And it's a simpler way to express a pattern. It sort of looks more like a real traditional knitting pattern. And they provide Java-based software to convert from Knitting EL into KnitML, and then you can pass KnitML onto subsequent programs, as I mentioned, so validators, renderers, and visualizers. So don't believe me, here is an actual open source visualizer called Knitter that processes a KnitML pattern and produces a three-dimensional model of the resulting knitted fabric. And I believe you can even stretch it and see how it responds. So that's really cool. I find that super exciting. And that sort of thing wouldn't be possible without a new standardized specification. But I know when I stand in front of an audience of engineers and say a new standardized specification, what you're all thinking. And to the extent the XKCD is true, KnitML sadly has not taken over the world. It's not taken over the world in the way that I would prefer. People are still publishing patterns in the old ways, filled with redundant information, lots of errors. It's just, I don't know. They need new marketing on that open source project. But thankfully, the world of open source knitting is a lot bigger than just KnitML. If you go to GitHub right now, and this screenshot's probably already out of date, there are hundreds of repos. Since Apache brought out that yarn thing, you now have to exclude stuff to not get all that. But there's Go language implementations of knitting pattern parsers. You've got custom row counters for your smartwatch, apps for turning JPEGs into charts, the source code for a knitting ipsum generator, for your next mock-up. Instructions for wiring your own row counter, which only slightly looks like a bomb. This is a really cool one. This is a pattern from Knitty.com. This is a bag, and they give you the pattern to knit the bag, which you then felt in your washing machine. And then you use a LilyPad Arduino, which is a sewable Arduino. You sew it in with conductive thread with a button and LEDs, and then you load your next pattern into the Arduino. And by pressing the button, it lights up the lights and blinks to tell you the next row of your pattern. How cool is that? Smart knitting bag. The next item I will actually model for you. So I made this for Camp.js a couple years back. So this, is it coming on? Yeah, there it goes. So this uses a Gemma microcontroller, which is a very small microcontroller. I mean, the cool thing about these sewable Arduinos is you can actually wash them. The battery, the power pack actually comes off and you can wash it. So it uses a Gemma microcontroller, 6 LEDs, and a coin cell battery, and it keeps you safe when you're on a very misty mountainside. This one is cool. I saw this a few months ago, Sweaterify. So this lets you upload an image. I uploaded Tux, and it imagines it knitted into an ugly Christmas sweater. And you can even download the pattern as a CSV so that you can actually knit it yourself. And the other cool thing about this tool is it was built by Mariko Kosaka, who some of you I know are aware of. Kosamari on Twitter, I think so. And she did a really cool talk at JSConf a few years back called Knitting for JavaScripters, which you should actually look up on YouTube and watch. It's really good. She's a goddess, like I am just in her shadow. And one of the things she talks a lot about in the talk is one of the most popular crossover knitting and programming activities of the moment, which is hacking old knitting machines from the 70s and 80s. And these are very popular. If you don't know, that red one, that's an example of one of them. These were very popular. Brother made a ton of them, like the computer printer people. And you can get them on eBay for pretty cheap. Some of them actually used punch cards still up until the 80s to input patterns. Some of them were computerized and had like a little LED with buttons, and you could pick out a pattern from a catalog of hundreds. Some of them had like a little floppy disk thing. So hacking them usually involves making your own serial cable and then writing your own software to transfer new custom designs over to the machine. There's an open hardware project called Knittic that uses an Arduino as the electronic brain for the knitting machine that allows you to actually manipulate designs on the fly. Now, people are putting these to some very cool and some very weird uses. So on the cool side, the Neuro Knitting Project. They plotted brainwave activity into a knitted pattern. So they used a wearable EEG to record users' affective brain states while listening to Bach's Goldberg variations. And then they knitted it on a hack knitting machine. So there he is wearing his own brainwaves, listening to the music as a scarf. Cool. Another artist that I really love, I only just recently discovered, is Sam Meach. So Sam is an artist and video smith in the UK. He's video smithery on Twitter. And he did an exhibition last year with a knitting mill. The exhibition was called Unique Editions. And one thing they produced were these scarves, which are binary scarves. So each one encrypts a quotation, as I mentioned before, at 8 stitches per ASCII character. So the pink and purple one is by Herbert Red, and it says, "Art is pattern informed by sensibility." And the black and white one, you can actually buy these on his website, by the way. The black and white one is a quote from Alan Turing. "Machines take me by surprise with great frequency." I love that. That's so cool. And so the idea for this project actually came from a commission they got from the Open Data Institute for their co-founder, Tim Berners-Lee. So for all I know, Sir Tim Berners-Lee is walking around wearing one of these right now. Another project of Sam's that I really love was the Horse in Motion, which combines these passions for knitting and video. So he started with this little animated GIF, which is taken from that famous series of photographs that Edward Muybridge did of a horse galloping, and then at the end it explodes in fireworks. That wasn't in the original. But he then converted that into an image sequence and fed that into a hack knitting machine to produce a 12-meter-long strip of knitting, 4,878 rows long. It apparently took like 3 hours to run through, which equated to 272 frames of animation. And then he photographed the knitting and reanimated it. And it looked like this. Wow, go back. Is it going to play? Yeah, there it goes. It's amazing. You got to let it run for a while to get to the fireworks. Yeah, it's just so cool. And I think if you play it on YouTube, there's a couple like coconuts at the same time, you know? Like, anyway, I'll keep going. So another artist working in the knitted medium is Jeff Donaldson. He goes by the name Glitch House. I like his stuff. He does glitch art. So he sells a range of scarves and homewares called malware, W-E-A-R, that encode famous malware, W-A-R-E. So he's even knitted Stuxnet into a throw that you can put on your blanket, on your bed. So he uses this cool method where he basically assigns every pair of binary digits into a different color. So 00 is white, 01 is light gray, et cetera, and that's how he gets his colors. So again, you can buy his scarves, they're very cool. Now on the weird end of the spectrum, and warning, nightmare fuel, this is an artist called Andrew Salamone, and this is his machine knit identity preserving bitmap balaclava. He photoshopped images of his own head from every angle into a single rectangular bitmap and then knitted it on a hack knitting machine. Now, my favorite knitting tech project of recent years is KnitYak, some of you may have heard of. Fabienne Serrière, she's FBZ on Twitter. This got some press because she did it on Kickstarter. She is using a hacked industrial knitting machine, so a really huge one, in a shipping container in Portland, because of course, to knit provably unique scarves using elementary cellular automata. So you remember that old game of life thing that we all played with? You know, it's like that kind of stuff where you have a cell and then based on rules, it changes over time. So as a backer, I get to choose my own colors, the rule I use, and the starting row. And the rule determines how each subsequent row of the scarf will change, so as you can tell. And this is where things get really interesting because the more I learned about the project, the more I started to think a little bit more deeper about these bonds between knitting and computing. And so I'm going to get to my final topic here. So knitting is computation. I'm going to start with a caveat here. I'm a much better knitter than I am a computer scientist. So that's the caveat for you. But I've been reading this book. Has anyone ever read this book? Code. Yes. The Hidden Language of Computer Hardware and Software by Charles Petzold. I can't recommend this enough. If you work with computers but secretly suspect you don't actually know how they work, this book explains how they actually work. You know, he starts with circuits and relays, simple circuits like a flashlight, and then he builds up to how you use Boolean logic, create logic gates, how you turn that into a binary calculator, and you eventually get up to microprocessors and modern programming languages, and it's really easy to understand and really cool. And it got me thinking, like I said, about computation quite deeply. And you know, I've joked a few times in this talk about like the human brain being like the CPU in the knitting computer, but you know, how much of a joke is that really? Could knitting, I wondered, really be considered a type of computation? So as I normally do when I have deep thoughts like this, I turned to my partner Rod and I said, what do you think? Is knitting like computation? And he said no. He says, in his view, knitting patterns are more like a markup language, you know, like HTML. I'm like, okay, I can kind of see that. You know, obviously KnitML, the project is using XML as a way to define patterns. That kind of makes sense. So the pattern is like the markup language, and the knitter is just the rendering engine, you know, that kind of puts it together, and the knitted object yourself is your rendered object, is your rendered output. And I can accept that metaphor, like for simple things like scarves and stuff, that makes sense, but it has its limits. Like when you're talking about a complicated garment with lots of customization, with lots of options, with lots of sizes, it doesn't feel right. Like those patterns have a lot more complex logic. They've got conditional logic, they've got branching, they've got subroutines and coroutines, as I mentioned. And when you're knitting one of those and trying to keep track of all that, it feels a lot more like you're executing a program than just rendering HTML. So to play devil's advocate then, let's say that knitting patterns are computer programs. They are a valid programming language. So what else would we need for a knitting computer? Well, we need a CPU, which we've already identified would be the human brain. You know, it's responsible for both fetching the instructions and writing the data, which is knitting the stitches. RAM is basically your live stitches on the needles, which are eventually written and saved to external storage, which is the thing that you're knitting. You know, free memory could be represented by a ball of wool. You know, free memory, got heaps of free memory. And the knitted object itself would double as the output device. So did I just compare knitting to a von Neumann architecture? I kind of did. Now, if you're interested in this, there is a really amazing blog post called Towards a Computational Model of Knitting that you should look up. It covers things like the 4 clock cycles required by the default stitch processing operation, and how normal knitting needles are like a last in, first out queue, or first in, first out queue, but double points are a last in, first out deck, or vice versa. Like I said, not a computer scientist, but if you're interested in it, you should look it up. It's really cool. So I like that. But knitting, it still just didn't quite sit 100% right with me. Knitting still has some limitations as a programming language. Memory, for one, isn't really random access. Like, you're writing everything sequentially. And if you make a mistake and need to change something, you kind of pretty much have to go back. You can't drop down. There are ways, but it's really hard to drop down and fix something. And most critically, with like 99.99% of knitting patterns in the world, the output's pretty much predetermined. You know, you're not solving a problem. Nothing you do in a given row is reliant on what you did in the previous row. So you don't really compute anything. You don't arrive at any end result. And that bothered me, you know? It bothered me because I want knitting to be a computer language. And so I tried, like, what would a knitting pattern that was a program look like? And then I remembered knit yak scarves. So yeah, you can knit elementary cellular automata. You know, I can start off with a one-dimensional pattern of ones and zeros, whether they be different colors or knits and purls, and that can change over time according to rules. And this, I don't know if anybody can identify it, this is rule 110, if you look it up on Wikipedia. And the really cool thing is around the year 2000, a guy named Matthew Cook proved that rule 110 is Turing complete. This rule is capable of universal computation. So this is the key. given an infinitely long ball of wool and an infinitely long set of knitting needles, I can simulate any Turing machine and by extension the computational aspects of any possible real-world computer. I can literally become a knitting computer. And there's where you get the mind-blown gif happening. Very cool. Yeah, thank you, sir. So I'm just going to finish. I added a little bit on recently. In January, I went to LinuxConf, and I saw a great talk by Nat Dudley on lessons that she felt the tech community could learn from the knitting community. And I thought that's a really great, just final little note to put on this. So I'm going to talk to you about 3 lessons. And the first one is in fact the one that I personally learned first, and it was simply humility. Like I said, I thought that because this hobby was done by grannies, by little old ladies, that it was that involved sticks and string, that it was somehow way simpler than what I do with computers and high tech, that it couldn't possibly be as complex as my day job. And I hope I've shown you that that's just crap. That's not true. I did this talk and I had a guy come up afterwards and say, so when you're knitting that one with all the different things, how do you have to keep track of all those numbers? And I was like, yes, dude, I use spreadsheets for this stuff. There are apps, this is complicated stuff. And there are women who can keep all of this, and dudes, who can keep all of this in their heads. That's just really amazing. So you shouldn't assume that just because something looks simple, that it is not as complicated as what you do. Documentation. I think we can get a lot better at documenting things. Just personally as a knitter, I learned very quickly that I needed to keep notes, not just of those really complicated patterns, but I go out with my newest object and someone says, oh, hey, Kris, what wool did you use for that? I don't remember. I just had to get very quickly in the habit of writing stuff down. And that's where Ravelry is really good. They prompt you, and because their model is amazing of cross-referencing all this information, the community benefits by you documenting your own stuff. It's really cool. I can go in and look for specific wool and see everything everyone else has knitted with that wool. That's amazing, and that's not possible if we didn't document all that. Meanwhile, I go to GitHub because I find something I want to use, a bit of code, and it hasn't been touched in 2 years, and there's nothing telling me, did it work? Did it not work? Does it have a massive flaw? You know this. This happens to you all the time. Isn't it that joke that you ask a question, you find a Stack Overflow from 7 years ago, one guy, and it's never answered, and you don't know? That's what we need to get better at. We need to get better at documenting both our successes and our failures. That really is helpful to the community, to people who are starting out. So, I think a lot of times we don't document stuff because we assume everybody knows it. Don't assume that. Put it out there in a blog or on GitHub and make sure you say, if something doesn't work, that's almost more useful than the stuff that does. And lastly, I think we can do better at welcoming newbies. I think there's always a tendency by the old guard in any hobby to kind of look down on new people who start, especially new people who come in all fired up about the shiny, shiny newness. So for the knitters, this stuff, this was called feathers. So look, 5-10 years ago, knitting was down. It was dying. It was dying. It was nearly dead. And then some enterprising yarn company brought out this stuff, which I'm sure is made of old garbage bags. But it reignited the community, and a whole bunch of new people came in. And they were very excited. And of course, yes, everybody looks down, but a lot of them stick around. And now that the feathers fad is over, they're still in the community. I'm probably one of them. I think I knitted a feather scarf. And I think, in tech, let's say the latest JavaScript framework, just throwing it out there. How many times do we look down on the people who get excited by just using the latest thing without really knowing the whole history of what we know? And I think we need to welcome those people because you want your open source projects to continue, you want your meetup groups to continue, you want the community to continue. You need to be more welcoming to those people. They'll become contributing members once they've got a little bit more experience. So just give them a chance, be more welcoming. So I hope this has entertained you. I hope this has maybe stretched your mind a little bit. If you, like me, sit in front of a computer all day long, I just got to say, knitting is a great way to relax. It's tactile, it's creative, you get something nice and soft and awesome out of the end of it, and you can even hack on it a little bit. So if you want to know how to learn, there are knitters here in the audience. You have an amazing knitting store in the city, Morris & Sons. They do classes. Go on YouTube. There's also knitting guilds. I'm sure we can find a way. Or in the end, you could always just call your grandma. Thank you.